3 toys in a bag is different than lining them up because you take all 3, you put them in the bag. That would be one way, right? So that would be 3C3, which is what I wrote up here. And then if you line them up, you give them a specific order. So it's 3 times 2 times 1, which is 3P3. The difference between the NPR formula and the NCR formula is this one has an R factorial on the bottom where it gets rid of the cases that don't matter. And then when we had 3 students from a class of 10 that are chosen to go on a school trip, we would take our 10, and we'd choose 3, fill it into our formula. We get 10 factorial, 7 factorial, 3 factorial. All right. 10C3 is the same as 10C7 because if I fill it into the formula, 10 factorial over 10 minus 7 factorial, 7 factorial. Does the order in which these are, 7 factorial, 3 factorial, and 3 factorial, 7 factorial matter? It's multiplication, right? It doesn't matter. So they end up being the same. This only works because of that extra R factorial in the C formula. Okay? So a caveat. What if I gave you this? Just a side note because I'm using this question. What if I gave you 20C16? What would you tell me it equals? Same as. We use the last example, 20C3 or 10C3 equals 10C7. 20C16 equals 20C4. What would you do?
Minus 16.
Right. Because what's happening is you're getting that common difference between them. So this one 10 minus 3 gets me that 7 first. This one 10 minus 7 gets me that 3 first. Right? So it is just a common difference. So what I could say is, how did I get this? You said you subtract them. Well, 20C16 just equals 20C 20 minus 16, right? It's just subtracting this, which is actually 4. Okay? It only works with C's. P's, that doesn't work. This one has an extra R factorial, and that's the reason why we can do this. The other thing they say to us is this here. So here we have it. NCR equals NCN minus R. This is the general form of it. Right, if you take those two and subtract them. The other thing on the formula sheet is it says this, and it's on your formula sheet. It says NCR equals NR. So if they ever give you a bracket with 2 numbers stacked, that's the same as NCR. There is nothing like that for P. It is just like that for C. It's on the formula sheet, so we have to know it. So for this question here, 3 students from a class of 10 go on a school trip. They're just going on a school trip, right? Those 3 people, it doesn't matter. There's no difference in if I pick first, second, or third, they get to go on the school trip or not. We discussed the way that that could be a permutation is give those guys jobs or let them go to 3 different school trips. Then it would be a P, right? So it is a C. I get 10C3. We proved that that actually equals 10C7, correct? We can also say an answer on the diploma could be 10-3. An answer on the diploma could also be 10-7. We need to know all 4 of these because they could ask any of them. They could give any of them as the multiple choice answer, correct? Some people will say, well, what if they give 2 of them? Well, they can't. They're both right, correct? So they can't do that. They would have to have one of the 4. So they could say 10 students from a class, or 3 students from a class of 10 go on a school trip and give the answer 10C7. And some people will sit there and be like, how does 7 work? If they said 3 people go. Well, 10C7 is the equivalent of 10C3. They are the same, right? So you need to know that you can interchange those. All right? So, next page. Lotto 649. The Lotto 649 is you pick 6 numbers from 49. Okay? And order doesn't matter in which you pick them. So if you had the numbers 1, 2, 3, 4, 5, 6, and they came out of the machine in 6, 5, 4, 3, 2, 1, you still win. Okay? So the number in which you pick doesn't matter. So here it says, to win the Lotto 649, a person must correctly select 6 numbers between 1 and 49. Jasper selected 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? So how many numbers does he get to choose from? Lotto 649. How many does he get to choose from? 49. And he chooses how many? 6. And it's a C because the order in which you get them doesn't matter. So you go to a little sheet. It has the numbers 1 to 49, and you just pick them, right? And then it lays them out in order on a piece of paper. So what's 49C6? Same spot as you go to get the P, but you're picking number 3. What's 49C6? It's a large number.
50.
13,983,816.
So, you have a 1 in 13,983,816 chance of winning the lotto, right? So some people say, well, then if 13,983,816 people bought tickets, someone would win. Is that true? What can happen with the numbers? People can pick the same numbers, right? So just because there's 13 million or 14 million people bought tickets doesn't mean someone wins, because you could have a whole bunch of people that actually have the same 6 numbers, right? Okay. Let's look here. The athletic council decides to form a subcommittee, a smaller committee, of 7 council members. Now this is the key thing. We need to have 7 people chosen at the very end, correct? Now we can decide if it's a permutation or combination whether those 7 people have different things happening, right? So if they have different jobs, or they need to do different things, or they're the head of vice president, president, secretary, treasurer, then it would be a permutation. But if it's just a 7 person subcommittee, and they don't have anything different, then if you're picked first or 7th, you have the same outcome, right? Then it would be a combination, because order doesn't matter. So let's keep reading. So we have a subcommittee of 7 council members to look at how funds raised should be spent on sports activities in the school. There are a total of 15 athletic council members. There's 15 total. Of those 15, I need to pick 7. Of those 15, 9 are males, 6 are females. The subcommittee must consist of exactly 3 females. Determine the number of ways this can happen. So, was there any jobs for these 7 council members? Anything different? Was anything stated in there? No. People will say, I need more information. No, you don't. You don't need more information. They gave you the right amount. This is a combination, because order doesn't matter. It's just 7 council members, right? So let's pay attention here. I need 7 council members. It says exactly 3 females. So that's cool. I need 3 females. What does that indirectly tell me? I need 7 council members. So what do I need? 3 females and 4 males. So if I went to go on a trip or something like that, and I said, okay, we're going to take 1 vice principal with us, and we need 3 teachers. How can I guarantee getting a vice principal? Go to the whole staff and pull a vice principal from it? How can I guarantee getting a vice principal? Choose them from what? The vice principals. Someone whispered it. The way to guarantee getting a vice principal is to choose them from the vice principals. The way to guarantee getting a staff member is choose from the staff members, right? I wouldn't choose from the school student population and the staff members to guarantee getting a staff member. I could chance getting a student, right? So if I want to guarantee getting 3 females, what am I going to choose from? The 6 females. So I'm going to go 6, C, 3. It's a combination because order doesn't matter because I have no specific jobs. Make sure you have a pencil in your hand and you're writing. And means I do what? Multiply. It's not an or, because if it was an or, I'd have 3 females or 4 males. Well, then I wouldn't have 7 people, right? I'd have 3 or 4. How do I guarantee getting 4 males? Choose from how many?
9.
The 9. Now type that into your calculator, and you can type it in all at once. 63 times 9C5, even if you have a TI-83.
9C4.
Yeah, why did I put a 5? Anyone? Climb into the brain and see why I put a 5. Yeah, 63 times 9C4. What'd you get? 2,500. What? 20.
Put the C in the bottom of the others.
Just, oh, you have to arrow up if you're on those ones. Yeah. So if you're on the fancy new ones, you have to watch yourself. Because if you go 6, C3, and then you go times, and then you go, what was it, 9, C4, it's now low, right? So you have to make sure that you, when you get to here 6C3, you arrow up, arrow over, get a multiplication, and then go. 9, math, C, 4. You know what I'm saying? So arrow that over. All right. Okay, example 4. I want you guys to try it out. Use pencils. A class consists of 5 girls and 7 boys, which is 12 total, correct? So if I just picked a 5-person subcommittee, let's say I just picked a 5-person subcommittee, I wouldn't care if you're boys or girls. I would go 12C5. People get messed up. Like if it's an easier question, you're all just like, I can't do it. How many boys or girls? It doesn't matter. So if it was just a 5-person subcommittee, I would go 12C5 because it wouldn't be anything about boys or girls, right? I just take all of them and I choose 5. But this one keeps going. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose this committee if there are no further restrictions. So I need 2 girls and 3 boys. How do I guarantee getting 2 girls? Choosing from 5. So I go 5C2 times 7C3. And what's the answer to that? 350. Okay, the next one uses those same things, but there's a restriction. It says Johnny, the principal's son, has to be on the committee. And I said to you, the only way you can guarantee getting Johnny is by choosing him from Johnny. But we're going to say Johnny, and then what do we need? And what? 2 boys, because Johnny's a boy and we already have one and we need 3 total, correct? And what? 2 girls. So I know this takes a little more pencil to draw that out. I understand that. But you will make less mistakes if you write out what the actual cases are with words, right? And then go behind. So how do I guarantee getting Johnny? I choose from Johnny. So I go 1C1. 1 Johnny, I choose Johnny. And means I what? Multiply. Now how many boys are left? 6. So watch yourself. Do you think the answer for 7 will be there? Yeah, that'd be a common error if you forget to take one of the boys off there. So we have 6C2 and 5C2. And what do we get for this one? 150. Pardon? 150. 150? Okay, the next thing is about cards. Some of you have never played cards before, so you don't even know what cards are in a deck. That's a legit thing. So, they're like, how do I know how many diamonds there are? I don't know. Well, you can't have a deficit because you don't have ever played cards before. So if you called me over and you're like, Mrs. Lepp, how many hearts are there? I'd say 13. You'd say, Mrs. Lepp, how do I do the question? I'd say, can't answer. Okay? So just if I tell you there's 13 hearts, I'm not giving you away the question. I just don't want you to say, oh, there's 4 hearts. You get it mixed up with something else because you never play cards. Okay? So if you wanted to ask me that, you could. On Diploma, they either give like an array which shows all the cards, or they'll make a totally different suit, which most of the time they do. They'll be like, oh, it's a card. This card deck has 4 suits. They're purple, green, orange, and blue, and they're numbered 1 to 6. Okay? All right. So, to break down a standard deck of cards, there are 52 cards. There are 4 suits: spades, clubs, diamonds, and hearts. 2 suits are black, which are spades and clubs. 2 suits are red, which are diamonds and hearts. Each suit has 13 cards, obviously, because 52 divided by 4 is 13. That's why each one of them has 13. It's an even amount. Face cards are the ones with faces. So jacks, queens, and kings. If you have jacks, queens, and kings, there's 3 of them, and you have 4 suits, that makes 12 face cards. So this says poker is a game played from a deck of 52 cards. Now most cards are combinations because the moment you get the cards, what do you do with them? You move them around. If it's hearts, you move them around with spades. Spades. Oh my gosh. You move them around in suits. If it's like Uno, you put the colors together and you possibly have like your ones that change. You're changing cards to the left or to the right or whatever. You separate, right? So the first thing you do when you get cards is you move them. So did the order in which they were dealt to you matter? No, not at all. If you were playing War, you literally flip the cards in the order they are. That would be a permutation, right? Because it would matter. But most card games, order doesn't matter. So this one doesn't. We have a deck of 52 cards. How many different 5-card poker hands are possible? How would I do this? How many do I have to choose from? 52. Because it doesn't say hearts, diamonds, black, red, queens, kings. It doesn't say anything like that. It just has 5 card hands. So I get all the cards, 52, and I choose how many? 5. And how many hands is that? 52C5.
2,598,060.
60?
960.
960. So there's quite a few actually different card hands in when you have 52 cards, you pick 5, right? 2 million, a lot. 2.5, we'll even over more, million. Okay, the next one says, in how many of the hands will there be all diamonds? So some people are like, okay, 52C3, 13. No, all diamonds. How many cards do I need for all of these? How many card hands am I picking? How many cards total? How many will be in my hand? Yes. So I need 5 cards, correct? So when they say all diamonds, what are they indirectly telling me? They need 5 what? 5 diamonds. That's it, right? They're saying I need 5 diamonds. From how many? 13. So I'm going to go 13C5, which is substantially less than 2.5 million. What is 13C5?
1,207.
So substantially smaller, which makes sense because I need 5 diamonds, right? Out of 52 cards, that's a much smaller amount. I want you guys to try the other ones. Please do it in pencil if you're a rebel who's using a pen. So, black cards, how many do we have to choose from? 26. Should I just be going and doing this right away, or should I have checked if they asked me for 5 cards? I should check first. 4 black and 1 red. Okay, cool. They've asked for 5 specific cards, right? So I can just go ahead. So 26C4, and means I multiply 26 red C1. What do I get? 700. Okay. 3 kings, 2 queens. Is that 5 cards? I stop talking. I don't think it is. This once. All right. 3 kings. From how many kings? 4. 4C3, and we do what? Multiply. How many queens? 4. And what do we get? 24. Okay, this one, people will give me 4C3. Do you think the answer 4C3 will be on the test? It will, because people will forget to add the extra cards, right? 4C3, 3 kings, and I need 2 that are not kings, right? I need 2 not kings. So can I include the 1 king I haven't used? No. It needs to be 2 that are not kings, right? How many kings are in the deck? 4. How many cards are in the deck? 52, which rhymes with 56, so very similar. So 52 minus 4 is how many? 48. So we have 48 left, and then we're going to choose 2. And what do we get? The next one says 4 aces. Is that 5 cards? No, it's 4. So I need 4 aces and 1 what? Not ace. You are correct. So, 4 aces. How many do I have in my deck? 4. And I choose all 4 of them. Remember we talked about this. If I have 4 objects and I choose all 4 of them without order, that's 1, right? 4C4 is 1. And then I have not aces. How many are not aces? 48, and I see 1. Choose 1. If I choose 1 at a time out of 48 objects, that's 48. So this is going to be 1 times 48, which is 48. All right. 5 cards of the same suit. How many suits are there? 4. So we're going to have to do either each suit separately, go 5 spades or 5 clubs or 5 diamonds or 5 hearts, which would be 13C5 for diamonds and, or 13C5 for clubs or 13C5 for spades, or 13C5 for the suit. I don't remember what I didn't say. Or what could I do instead? 13C5 times 4, which is how much? 5,440? 48? Wait, let's hear you. Okay. Then we're going to flip over. All right. In a meeting, everyone shakes hands with everybody else. So that just means everyone shakes hands with everyone, right? Okay, get ready. Cool. Now we're going to shake hands again. Cool. Well, now we're going to shake hands again. Some people do this in pairs. Your music cracks me right up. Sometimes people do this, the handshake. They just put their hand in, and then they make you do the work. Yeah. Or you just hold hands. It's really weird. Or they do this. Or they do the trump. Or they do like this. Or they do this. No, they don't, but that would be fine. I love parent-teacher interviews for the handshake. I like meeting all your parents. They're lovely too, but just getting to, it's just, and then you have to like, when someone shakes your hand like this, you are not allowed to laugh. Pleasure to meet you. So, when we shake hands, how many hands come together? 2. In this class, say there's 25 of you. I don't remember how many there are, but there would be 25, and then we would go C2. Why is it a C and not a P? Because the order in which those hands come together doesn't matter. They come together how they do, and then you shake. Or you wait, and the other person shakes for you. It's great. So, either way, it's a C when it's a handshake. So, we are going to go, in a meeting, everyone shakes hands with everybody else. Can we put the table down? I have a feeling this isn't going to stay, but that's just the feeling I have right now. Shakes hands with everybody else. There are 66 handshakes total. So, it's going to equal 66. Okay? Because that's the total. So this time I actually gave you the answer, which we haven't really done a lot before. How many people were in the meeting? So what did they not give me? N. You're right. They did not give me N. I know it's a C because it's handshakes in order, doesn't matter. What goes in R? How many handshakes go together to make a handshake? How many handshakes go together? How many hands go together to make a handshake? 2. So handshakes, this will always be a 2 because this is the number of people shaking hands at a time. Now it says show your work algebraically. I know that N has to be 2 or higher, correct? Because I can't go like 1 choose 2. That doesn't work, right? So I know it could be 2C2, 3C2, 4C2, 5C2. And I could do that to get the answer to know where I'm going. But if I just give that answer, I get 0 marks. Well, I would get I would get a little marks because I set up NC2 equals 66, right? So I would get some marks because you set that up correctly. But I wouldn't get full marks because it says show your work algebraically, and that would be no algebra. So when it says show your work algebraically, that always means to go to the formula. So my N is N, my R is 2. So I'm going to go N factorial over N minus 2 factorial, 2 factorial equals 66. So the difference between the C formula and the P formula is that extra R factorial on the bottom, right? But if we just get rid of that right away, we're back to the same thing we were doing in the previous lesson, right? How do I get rid of a division of 2 factorial? What is 2 factorial? It's just 2. How do I get rid of a division of 2? Times by 2. So I'm going to multiply this side by 2. That's gone. Multiply this side by 2. And I get N factorial over N minus 2 factorial equals 132. Am I not back to just where I was before when we did this algebraically? Same steps, right? So what do? I expand the what? The top in this case because it's the bigger one. And with these formulas, it'll always be the bigger one. So we're going to get N times 1 less N minus 1 times 1 less N minus 2 factorial over n minus 2 factorial equals 132. The n minus 2 factorials cancel, and then I distribute. So I get n squared minus n. And then I move my 132 over. Minus 132 equals 0. And then I say, what times what equals negative 132? What plus what equals negative 1? Negative 12 and 11. So I get n minus 12, n plus 11 equals 0. And I get n minus 12 equals 0, n plus 11 equals 0, n equals 12 is good. N equals negative 11 is what? Extraneous. Now do I just send it and hope for the best? No. I go 12C2 in my calculator. And I hope it gives me 66, does it? So now I'm happy. I walk away knowing I did this well, right? We're going to skip extension 2 for a second. We're going to go to extension 3. So extension 3 says every team in a league plays every other team 3 times. So every team in a league plays every other team in the league 3 times. Okay? Let's pretend that this league is hockey. How many teams played a time in hockey? 2. So please don't put C3. You're trying to tell me 3 teams played a time. Remember when we go C and we put a number here, it's how many hands shake at a time. It's how many teams played a time. So unless you come up with a random sport that has 3 teams, there's a soccer game that has 3 teams. It's the craziest thing. I don't even know how it works. But unless they come up with something convoluted like that, hockey, soccer, basketball, volleyball, 2 teams played a time every single time, right? So that's where the 2 comes from. Okay? Every team in a league plays every other team 3 times. We'll deal with that in a second. How many teams are there in the league? So what am I missing? Which am I missing? The total or n? N. How many teams are in the league? I don't know. If they play 198 games, the total of 198, so they gave me the n. This is if they play every other team, correct? But how many times do they play the other teams? 3. So I just take this and I times it by 3. How do I get rid of a multiplication of 3 really quickly? Divide by 3. And guess what I get? NC2 equals 66. It's the exact same thing as the previous one, correct? The same work. So the answer is n equals 12. Would this be sufficient enough work to get the answer correctly? No, I'm just saying it because you could say C above, right, for the work, for time mean-wise. Like it's going to be the same thing. I'm not going to test though. And you always need sentences. So this one, you'd have how many teams are in the league? You'd say there are 12 teams in the league, right? The previous one, you'd say there are 12. How many people are in the meeting? There were 12 people in the meeting, right? You have to have sentences when it's a word problem. Okay? We're going to do one more. It's extension 2. It says, there exists a circle with 6 closed dots on the circumference. Okay, cool. I'm going to draw that. Circle, 6 closed dots. 1, 2, 3, 4, 5, 6. All right. There are 6. There's a circle with 6 closed dots. How many triangles can be formed from the dots? How many dots do we need to make a triangle? 3. 3, right? Now we have to decide. Most people know it's going to be 6C3 or 6P3. They're just not sure which one. So we have to think, does order matter? So if I pick the triangle like this, or I pick the triangle like this, or I pick the triangle like this, did it make a different triangle? No. So is it C or P? C, because order doesn't matter, means C, right? Combination. So we're going to go 6C3, which is 20, I believe. There are 6 questions for homework. There you go.
I